Hi YouTubers, it's George. I'm in the garage workshop today and I'm going to talk about these low cost HF SDR transceivers, and they're made in China and you either love them or hate them, and they're battery powered and they're supposed to give 10 watts on 12 volt and 5 watts on the internal battery. But first of all, I'm going to go over the settings for you, what I've set my radios to. Now, the first thing you'll notice is this one with no aerial connected is showing S4 and this one is showing S3, but ignoring that totally. Now, to go into the settings mode, you press menu, right, and I'll go back to the very beginning. Right, the first setting is the volume, which is +2. Well, it's normally about 8 or 9 when you're listening to it. USB mode, bandwidth full, band I'm on 20 meters, tune rate 1K, VFO A, RIT off, AGC fast, noise reduction 0, attenuation 0, attenuation 2 0, S meter S, S meter forward SWR, CW decoder off, semi QSK off, keyer speed 25, keyer mode straight, keyer swap off, practice off, Vox off, noise gate 1, TX drive 4, CQ interval 5, then the CQ message, PA bias minimum 30, PA bias max 200, reference frequency, IQ phase 90, backlight on, which you can't turn off by the way. Now I set the PA bias to do with the band I'm using for transmit, and what I do, I normally use a 20 meter or the 40 meter, and a combination of the bias. I switch it to CW mode with a dummy low connected, I press PTT and I set the bias so it gives me about 5 watts on either the 20 meter or the 40 meter band in CW mode, and that's what I stick with, those settings. But it varies from, obviously, from device to device, the bias setting you need, but that's the bias settings I've got on my radios. Now these radios are QRP low power radios, so you're not going to get a lot of contacts on them unless you have an amplifier on the end of them. But one of the problems I've found is, since owning them over a year, I've only managed to make 8 contacts, and for the following reason. And the following reason is, I've found people on the QRP calling frequencies using a kilowatt and all sorts of power. Even local hams who are in the UK talking to no other using 200 watts on the QRP calling frequencies, which is not on. The QRP calling frequency on 40 meters for phone is 7.285 megahertz, or Europe 7.090 megahertz. On the 20 meter band it's 14.285 megahertz, and on the 17 meter band it's 18.13 megahertz. Now these are the calling frequencies for QRP operation. Now it's recommended that, for example, if you're calling on the 20 meter band, you call 20 minutes past the hour for CQ. If you're on the 40 meter band, it's recommended you call 40 minutes past the hour when you're calling CQ. But as I say, if you've got these radios, the quality is a bit hit and miss, and as I say, I've only had about 8 contacts on QRP, and because of competitions, people blocking the airways, interference, all sorts of problems. So that's about it. I'm going to talk about those, but what I'm going to next talk about is the microphone, and it is a speaker microphone that came with one of these radios, and I'm just going to go over the electrical connections because I've had a few questions regarding it. Now, the microphone that was supplied with one of the radios didn't work, and very simply it was wired incorrectly, and what was happening is it wouldn't transmit and one thing another. I've moved the wires around and got it to work, and I've also done another video on it, but there's been quite a few questions relating to it. Can this white wire here I've put on be connected to the speaker positive? The answer is yes, it can, because it goes to the same place. And here's the wiring connections which are correct for my radio, so I'm assuming if you've got this microphone with your radio and it don't work, this is how it should be wired inside. Now, one thing I will say is, from the black wire to the PTT line with a voltmeter, with the black lead on the black and the red one of the multimeter or test meter on the PTT, should be 4.7 volts, near enough. It's not that accurate. The microphone, if you check the microphone with the voltmeter, black is on the ground, and the voltage on the mic connection here should be 2.5 volts, because the microphone insert requires a voltage on it for it to work. Now this is in the receive mode, so all you do is you put the radio on, take the microphone apart and measure, and if you stick to this wiring, I don't think you can go wrong. It should work. So once you've changed the wires, you should be able to hear the audio coming through the microphone like that. Okay. Now, to prove it's transmitting, if the band you're using is like, I don't know, the 20 meter band, set it to USB, and if you actually blow into the microphone, you'll see the display very subtly will go up and down in brightness as you speak, or flicker. That's telling me that the audio is modulating the RF, and it's drawing current, which is making the display just dim down very, very slightly when you blow into it. Or if you've got another receiver, put it on the same frequency and you'll be able to listen to your audio as well, which will be probably distorted. In both cases in this radio, I modified the level of audio that comes out the speakers, because I wanted more coming out of the speaker mic than coming out of here. So very simply what I did, I matched it with some resistors to drop the amount of audio coming out the internal speaker, Originally it's an 8 ohm, and the audio amplifier needs an 8 ohm match roughly. So what I did, I found some resistors that were near 8 ohms. I put it across, I disconnected one of the wires from the amplifier. I put another resistor across the speaker. So if you put resistors in parallel, you basically halve the resistance if they're the same value. So that circuit there become 4 ohm, and then what I did, I put a 4 ohm, I think it was 4.7 ohm in series, and I get the impedance of 8. So what it's done, it's dropped the audio level from the internal speaker, which means you have to turn the volume up more, but it means you get more sound from this speaker microphone. I hope that makes sense. So you disconnect one of the wires to the speaker in the radio, you solder across the speaker a resistor as close to 8 ohms as you can get, and you put a 4 ohm resistor in series like here with one of the wires you've cut. So the amplifier in the radio sees 8 ohms, and half the sort of power here is going into this resistor in here. So it reduces the output level from the internal speaker, and you can rotate the volume here to give you the level you want on the speaker mic. And that's a simple modification I did. It's a bit fiddly to do because you have to dismantle nearly the whole radio to do it, but that's what I've done. So I hope this video is useful, and thanks for watching. Please subscribe and like.